So lesson 6 says using permutations and combinations, NPR and NCR. Now I'm going to be honest, Chelsea, I hardly ever use NPR, because if the order matters, even if it's a 5-level tree, if the order matters, it's only one branch, a specific branch, and I can just write out the fractions. So although I said using NPR and NCR in here, we're going to mostly do NCR. But it says this: for experiments with only a few draws from a deck or from a pot, it's usually easiest to do a tree. What I've said to you, Brianna, is if it's 2 things, tree. 1 thing, count. 3 things, maybe tree. More than that, today's lesson. As the number of draws gets larger, the number of branches that you're drawing gets more and more, and the tree method becomes very tedious. So, we're going to start with 2 cards, see if we can get there using counting methods, and then see if we can generalize it. Now, I would never do a 2-card draw using counting methods. I'd do a tree. But if we can get the same answer using counting methods, then we can trust when it's more than 2 cards that our counting method works. Method there. There's method to my madness. Comparing the methods. So suppose 2 cards are drawn. Can you all underline without replacement? That's important. It means the odds are going to change on the second branch. Calculate the probability that they're both aces. So we have 2 events, card 1, card 2. We have ace, not ace. Let's fill in the weighted branches. What's the probability that we are an ace on the first draw? 4 out of 52. What about not an ace? 48 out of? Now, down the left-hand branch, we picked an ace. So what's the probability that we get an ace on the second draw? 3 out of 51. What about that we don't get an ace on the second draw? 48 out of 51. Down the right-hand branch, you didn't get an ace. What's the probability that you get an ace on the second draw? 4 out of 50, 51. And, what about not an ace? 47 out of 51. By the way, are these 2 branches identical to those 2 branches? Then these are dependent, not independent, which I knew because anytime I'm pulling cards and not replacing them, I'm going to change the odds after every single pick because it depends on what I hold in my hand. What do they want me to find here? Calculate the probability that what?
They're both aces.
Okay, which is going to be, hey, that branch there, right? It's going to be 4 out of 52 and 3 out of 51. It's going to be 12 out of 26, 52. I've done 52 times 51 so many times I have it memorized. But what is that in lowest terms? You can either do the fractions or reduce. What is that in lowest terms? I think it works out to 1 out of something. 221, I think, but double check me.
Yeah.
Is it? I would imagine if you were a professional card player trying to make a living doing this, you would have most of those memorized, although you would have it for 7 cards. And 7-card Texas Hold'em is a bit trickier because some of the cards are displayed and some are not, and so that makes it a more difficult question. So that's why I'll stick with standard 5-card poker where you look at your 5 cards and no one else gets to see them. Okay? Now, no problem. What if we did it using combinations? The sample space is a list of all the possible ways to select 2 cards from 52 cards. Is this a deck of cards? You know what? Maybe I can handle this with a bucket. With aces and not aces. Remember this from last unit. How many aces are there in the deck grand total? How many non-aces? Now, for this particular situation, how many aces do you want to choose? How many non-aces do you want to choose? It's a trick question. None? So it seems to me the number of ways to select 2 aces is from 4 aces, and I'm writing this on the second line, choose 2, and from 48 remaining, choose how many? 0. Now, that's the number of ways to pick 2 aces. How many ways are there to pick 2 cards? How many cards are there in the deck grand total? On the previous line, 52 choose. That's how many ways to pick 2 cards. Believe it or not, look up once you've written that down. This is the number of successes. This is the total number of outcomes. This goes back to our very original definition of probability. Probability is defined as the number of successes over the number of outcomes. If you go 4 choose 2 and 48 choose 0 over 52 choose 2, try that, please. I bet you'll get 1 over 221. Now, you're going to have to remember, and I'm not telling you, where the heck is that probability menu? If you forget, I'll show you in a second, but see if you can find it on your graphing calculators, please. If you got your calculator in your locker, go get it, please. Yep, you're going to need it. Where's yours? Okay, where's yours?
Oh, I made a foolish mistake. I allowed someone to borrow mine for their success. I haven't gotten it back yet.
That's 2 foolish mistakes in one, I think. Okay, now for those that have your calculators here, okay, it was option, arrow sideways, oh, that's why this was under the probability menu, because we're going to be using it here. So it's going to be bracket 4 choose 2 and 48 choose 0 divided by 52 choose 2. Please tell me I get 1 over 221? I think I get a decimal initially. Oh, wait a minute. I have this lovely fraction to decimal button. And I get 1 over 221. Fraction to decimal button's right there. F to D. It works, yes? You know what? This gives us a general method that we can extend. This gives us a general method to... By the way, the order really is implied here. If you have to pick both of them aces, you're going to pick the first one and the second one. So order really doesn't matter, because the only way that you can get 2 aces is if you get all aces. That's why it's a choose. Here's what else I want you to notice. Look up, look up, look up, look up. This plus this, donk. This plus this, there's a built-in error check here. The front plus the front should add to the front of the bottom. The back plus the back should add to the back of the bottom. Darian, question? Hang on a second. You can also do this with permutations, but I'm going to tell you I'm not a big fan of using permutations for card questions, because when you play cards, unless they specifically mention first, second, third, fourth, fifth, the order when you play cards doesn't matter. You don't care when you got the ace. You only care if you got the ace. So turn the page. And here is our trigger. Here is our trigger. Brandon, can you read to me example 1, please? Stop. How many cards?
5.
This is not a tree. That's your trigger. Oh, more than 2? Probably I'm going to use combinatorics. Keep reading.
5 cards are drawn without replacement.
Without replacement, that means the odds are going to change every time. We could do this with a 5-level tree. Ugh. Keep going.
From a shuffled deck of 52 cards, determine the probability of each of the following events.
Okay? Now, in A, I started to walk you through it, but I'm going to say I think we can do this with a bucket. What's event A? The 5 cards are all?
Spades.
So my bucket is going to have 2 categories. What 2 categories is my bucket going to have?
Spades and
How many spades are there in the deck? How many non-spades are there in the deck?
39.
Okay? How many spades, Brandon, do we want to pick in example A? How many non-spades? None. So this is a probability question. The top is going to be from 13, choose 5, and from 39, choose none. That's how many ways there are to pick 5 spades. To turn it into a probability, I have to divide it by how many ways there are to pick 5 cards. How many cards are there in the deck grand total? How many are we choosing? And again, your built-in error check. You may notice that that plus that adds to that. And you may notice that plus that adds to that. Do you have to put it in brackets? I don't know. Do you have to put the top in brackets? Let's find out. Bracket 13, choose 5, and 39, choose 0, divided by 52, choose 5. You know what? With one thing in the bottom, it doesn't look like I had to put it in brackets. Do you get 33 over 66640? A little unusual, but okay. 33 over 66,006. Oh, you know, that's a small number. Why? This is a straight flush. Sorry, this is a flush, spade flush. It's a good hand. Not the best. Straight flushes are better, but this is a pretty good hand. Second best hand after a straight flush. Okay. 33 out of 66640. B. 3 spades and 5 hearts. Sorry, 3 spades and 2 hearts. How many categories am I going to have in my bucket this time? 3. Good. What are they going to be? Spades, hearts, and let's call it others. You could also call it not SH, but whatever. How many spades are there in the deck? How many hearts are there in the deck? 13. How many others? How many spades am I choosing? 3. How many hearts? 2. How many others? None. By the way, I hope, Alyssa, you can see this is really easy to modify. What if I'd said 3 spades, 1 heart, and 1 other? Just, I got to change a couple of numbers, but it still works. So it's going to end up being 13, choose 3. There's my 3 spades. And 13, choose 2. There's my 2 hearts. And 26, choose. There's don't pick any of the others. All divided by what? Oh, does it work if I add up everything in the front and everything in the back still? Yeah, it does. From 52 cards, you're choosing 5 of them at random. That's how many different 5-card hands there are. So that's what you're going to divide by. This is how many positive outcomes there are. Which is what? What is it? 143 over what? You trail off every time. 16660? Okay. Is that right or no? Yeah? You're getting decimals, and I'm going to figure out how we can change yours later, because you got the older models. Yeah. Type that in and see if you get the same decimal, and you know you're right, right? Let's skip C. Let's do C. Try C on your own. 3 spades and 2 non-spades. Huh, I'm being clever. I'm just backspacing. That works. There's the decimal and the fraction. Is that right?
Yeah. Mm-hmm.
Oh, and by the way, Kyle, you can see I said to you at the very beginning of this unit, we're good at very basic probabilities, but after there's no way you're coming up with that in your head while playing cards. Oh, it's 2,717 out of 33,320. That's the probability that I get 3 spades and 2 non-spades.
Is that the lowest possible?
33320. Is that the worst possible hand? Nope, because that's still 3 of one color. I think the worst possible hand would be 1, 1, 1, and 2 with 5 cards. Only 2 spades. Okay, if I did D, only 2 spades, how many others must there be? 3, so your bucket would be the same as before, but it'll be 13 choose. Oh, you know what? You have it on your calculator? It's just going to be 13 choose, if I backspace 2, and 39 choose 3. There. 27% chance. Or you could change it to a fraction. I'm going to pass on D. E is a better hand. 2 aces, 2 kings, and 1 other card. Is it a good hand or a bad hand? 2 pair, 2 high pair, pretty good hand. How many divisions are there going to be in my bucket? 3. Aces, kings, others. 4 aces, 4 kings. Ooh, how many others? And again, hopefully you're using the complement. I mean, you can count, but 44. 2, 2, 1. 4 choose 2, and 4 choose 2, and 44 choose 1. All over. Oh, 52 cards. Choose 5 of them. Four choose 2, and 4 choose 2, and 44 choose 1, over 52 choose 5. I'll leave it as a decimal. Do you get 6.09 times 10 to the negative 4.000609? Or as a fraction, for those of you that can, 33 over 54,145. It's a pretty good hand. $33 over, what was it, 54,145? But that's really the probability of getting any 2 pair. Because you could also then, so if you wanted to find out the probability of getting 2 pair overall, you'd multiply this number by the number of different ways to get 2 pair, which you could also, I think, figure out with the fundamental counting principle. Is that okay? Next page. Three prizes are awarded in a raffle. 100 people hold one ticket each. Okay. What's the probability that A, B, and C win first, second, and third respectively in that order? Oh, now, this is technically a permutation. But Chelsea, do you recall I said to you, Rachel, I usually don't worry about using the whole NPR thing, because if they give it to me in order, they're only talking about one specific branch, and even if it's a 3 or a 4 level tree, I can draw it. In other words, as a branch, here's what they're talking about. A wins, then B wins, then C wins. That's what they're talking about, because they said respectively in that order. How many Alices are there in the deck? 1 out of how many raffle tickets are there? So Alice has a 1 in 100 chance of winning first prize. Okay, she just did. How many tickets does Ben have left? 1 out of how many are left? Hey, Ben won. Good for you, Ben. How many tickets does Conchetta have left? 1 out of how many tickets are there? So, you know what? I don't think that's significantly a large amount of work. And even if it was a 4-level tree, I could fill it in. If it's a single branch, I've done as many as 6 on a single branch. I can just follow it. If they tell me the order, Rachel, I tend not to. There is a way to solve this with NPR and all that. I tend to just draw it out. Because can you see it's going to be multiplied down now? It's going to be 1 out of 100 and 1 out of 99 and 1 out of 98. Which turns out to be the same as 1 out of, from 100, permutate 3 of them. I think those are equivalent numbers. You can double check me. But, Mac, I'm not that comfortable using that method. I'll write it there and leave it uncrossed out. But I would draw the tree because it's only a single branch because they told me the specific order to follow. Does that work? Is 1 over 100 times 1 over 99 times 1 over 98 and is 100 divided by, is 1 divided by 100p 3? There you go. As a fraction, 1 over 970,200. Almost 1 in a million. That particular combination occurs. Sorry, that particular permutation occurs. B, what if all you care about is that each of them wins a prize, but not necessarily in that order? Bucket. Bucket. And my bucket is going to be made up of winners and losers. Out of the 100 people, how many do we want to win? 3. How many do we want to lose? And of those winners, how many of them do we want to choose? All 3 of them. Of those losers, how many of them do we want to choose? 0. Oh, can you see the equation? What choose what choose what, over what choose what? It's going to be over 100 choose 3. It's going to be 3 choose 3 and 97 choose 0. Now you may recall, what is 3 choose 3? Do you remember from 2 units ago? It's 1. And you know what 97 choose 0 is? If you're really lazy, the answer is going to be 1 divided by 100 choose 3. Hey, look at that. I can backspace and just hit the choose button. Oh, and delete that. 1 in 161,700. So now we can deal with Lotto 649. Because, hey, you never know. Well, sadly, you do almost know. So in BC 649, they pick 6, and you have to pick the 6 winners. So before the draw, you select 6 winners. What's the probability that they pick all 6 of them? So we're going to have a bucket. And my bucket is going to be made up of winning numbers and losing numbers. How many winning numbers are there? How many losing numbers are there in BC 649? 43. If you want to win the grand prize, how many of those winning numbers do you want to choose? If you want to win the grand prize, how many of the losing numbers do you want to choose? You've always wondered. Over what? 49, choose 6. Oh, because it doesn't matter what order they pick the numbers. They put them in order when they display them on the screen just because that's easier to read, but it doesn't matter what order they pick your numbers. It just matters if they pick your numbers. By the way, I think the top works out to 1 again, doesn't it? It's 6, choose 6 over 43, choose 0. It's 1 times 1, so it's 1 over 49, choose 0. 49, oh, choose 6, Mr. Dueck. That makes way more sense to me. That seemed like a really easy, hey, if those are the odds, put your money in now. That's a guaranteed investment. Yeah. Chance of winning, 1 in 14 million. Well, 13.98 million. 1 over 13983. Now, you can also win a prize if only 5 numbers are picked. So really, if you're asking what are the odds of me winning, the answer is, well, you can win with 6 or with 5 or with 4 or with 3. What does or mean? You could find each of those individually and then just add them up. And that's where the whole chance of winning 1 in 14 million comes up, because this would be a little bit bigger when you added up the other ones in. In fact, hey, instead of only 3 numbers, 5 numbers. That's the second best prize. You know what? If I was clever, I would have typed in the top, because then I could just backspace and edit. 6, choose 5, and 49, choose 1, divided by 43, choose 1. Thank you, Ben. 49, choose 6. So here's 5 numbers. Geez, Dueck, get this right. Small 6, big C, 5, and from 43 losers, choose 1. All over from 49, choose 6. Okay, and this is usually a pretty big prize. It's usually several, in the tens or 20s of thousands, I believe. 43 over 2330636. Is that right? 2330636. Then you could figure out 4 numbers, and then I think the last that they give you like a free play or something is with 3 numbers. Well, to be honest, Darian, I don't know. And I'll tell you exactly the same thing that my math prof told me in university. You know what? I win $14 every week on Lotto 649 because I don't buy a ticket each day. There's the math. I have a bit of a chip on my shoulder towards lotteries. I think they're a tax on poor, stupid people. Really, I do. People say, well, wait a minute. Some of the lottery money goes to like fund hospitals and stuff. So it helps them raise money. You know what? If the lotteries weren't there, they would have to still spend that money on hospitals and on education. What it really allows them to do is spend stupid money on other stuff and not have to spend the original amount of money on useful stuff. There's a reason why more and more governments are going into it, though, because it's easy money. So I'm going to say about 40 years ago, I think there was only 1 or 2 lotteries in North America. I think almost every state has one now, and you've seen some states have combined them. What's the really big Uber one in the U.S.? Yeah, the big Powerball. And you know what? They're making a profit off of it. It's a tax on poor, stupid people. I worked at a gas station for a while in Abbotsford, and whenever the lottery prize would get big, like in the $20 or $30 million range, you'd have people that would go all up and down South Fraser Way, which is the equivalent of the Lougheed Highway, Dewdney Trunk Road here in Maple Ridge. And they would plunk down $50 at each gas station. Oh, and the reason they were going to different gas stations was to improve their luck. That really doesn't affect your luck at all. No, if I buy tickets at more than one location, that means I'm more likely to win, right? Because if I just bought them all in one location, come on. Oh. I'll give you another one. I tried talking somebody into picking the numbers 1, 2, 3, 4, 5, 6. Because isn't that as likely as any other series of numbers to come up? Couldn't get them to pick 1, 2, 3, 4, 5, 6. No, that'll never happen. That's an unlucky number. That's less likely to come up. No, it's just as likely as any other stupid numbers of 6 that you're picking. Right? Mm-hmm. Come on. Oh, I saw some bad math. No, you can only, the numbers all have to be different.
Oh, they all have.
Yeah, because they're picking from 49 different digits. They're picking 6 of the balls out. So it has to be 6 different digits. Yeah. Another great one, try convincing somebody to pick the same numbers that won on the previous draw. You'll never be able to. But I'm telling you, it's the same odds as any other number. Well, no, twice in a row. It resets every time. It's independent. It's not dependent. But boy, bad math. Bad math. Bad math. Can you please go to your workbook and open to page, in your workbook, 167. Page 167. We're going to do some nastier ones now, building on it. So specifically, can you, once you're at page 167, look at example 2. So we're again dealing with 5 cards. We've already done A and B. How would you handle C? How many 10s are there in the deck? How many do you want to choose? So, now this would be a straight. 10, Jack, Queen, King. Well, it all depends. There are some variations of poker that won't allow a straight to carry over from the king back to the ace, depending on which way you play. But, okay, this one would be, what? Tens, jacks, queens, kings, aces, and others. So 5 different cards is going to give you 6 categories in your bucket. There's 4 tens, 4 jacks, 4 queens, 4 kings, 4 aces. How many others? Use the complement. 1, 2, 3, 4. Oh, it's 5 times 4 is 20. Really? You had to go 52, take away 20 on your calculator? 32 others, right? And I want 1, 1, 1, 1, 1, none. Now here's the nice thing. What is 4 choose 1? Who remembers? What's anything choose 1? So anything choose 0 was 1. What was like 6 choose 1? What was 8 choose 1? 6 choose 1 is 6. 8 choose 1 is 8. 10 choose 1 is 10. 4 choose 1 is? This is really 4 times 4 times 4 times 4 times. How many 4s? You know what? This ends up being 4 to the 5th. And from 32, choose none. By the way, what's 32 choose none?
1.
Okay, so I don't need to really put that there. Over from 52, choose 5. That'll get you there. What if I want to go away from cards? Well, I could go to Scrabble tiles. Example 3. Oh, I guess you guys want the answer. Okay. 4 to the 5th divided by 52, choose 5. As a decimal, it's 3.94 times 10 to the 4th, or 64 out of 162,435. Oh. I'll go 3.94 times 10 to the negative 4, 0.000394. Can anybody see what the key phrase in example 3 is that would tell me how I'm going to do this? That would tell me that I'm not using a bucket? No, we're example 3. You scooch down to the next question already. Don't. My fault. There's a phrase in here that tells me don't use a bucket. What? I think I can do this with a tree. Because it wants me to get the letter C followed by an O. How many C's are there in the deck? 1 out of. How many Scrabble tiles are there in the deck? Okay, you picked a C. How many O's are there in the deck? You know what? I'm pretty sure it's going to be 1 out of 42. What does B want? You know what? It's going to be vowel 1, vowel 2. Because it's only one branch, Brianna, I think I can handle this without bringing in permutations. Gonna make it there, Jordan? How many vowels are there in the Scrabble tile deck? Out of? So it's going to be 3 out of 7, 2 out of 6. It's going to be 3 out of 7 and 2 out of 6. Excuse me. He already has, thanks. I think you get 1 out of 7 in lowest terms, yes? All right, let's turn the page, see what else they got. Ooh! MP3 player. Okay. His player contains 50 songs. He listens to 10 songs on random. How many cards is he choosing? 10. It's the equivalent. How many cards are there in the deck? 50. Okay, I've got my hook. Determine the probability that the playlist contains Mike's 2 favorite songs. Did it say when those songs had to occur?
No.
Bucket. Okay. His favorites, not his favorites. How many of his favorites are there? I heard someone say 10. I heard someone say 2. 10 of his favorites? Read part A. How many favorites does he have? How many other songs are there left in the deck? Relax, ready? How many of his favorites is he choosing? 2. Brendan, how many of his non-favorites must he choose if he's picking a total of 10 songs? That number 10 is like the 5-card hands that we were doing on the card questions. The 5 didn't blatantly appear in the question, but we used the complement trick to figure out how many of each we had to pick to add up to a total of 5 cards. What's it going to be? 2, choose 2, and 48, choose 10. All over, what, choose what? Sorry, 48, I wrote a 10 here, guys. You said 8, right? Gosh, I need to listen to my brain more. 8. You're going to catch them? I caught myself. I give myself a candy. On the bottom, what, choose what? And my trick of adding the front to get to the front and adding the back to get to the back still works. Brendan, you see this is actually a card question in disguise. I have to translate the numbers carefully, but it's a card question in disguise. You see why it's 2 and 8? Okay. Which is what? 9 out of? 9 over 245? Anybody else? Yep. Okay. B. Skip it. I'm not going to go that tricky. Committee questions. I'm going to make it a card question, so I'm going to say no. Now, what did I assign from the homework? Can you read it to me from the notes?
Numbers 1 to 6.
1 is good.
Yeah, he said we were working on lesson 5 because most of it's been attention.
Okay, so I'm going to assign this stuff next class. You're also going to get a take-home quiz, I think, next class. And we are done the unit. I do have a great big uber huge review. It's from my old Math 12, and so it also has some of those last type of questions that I said I'm not going to cover this time. I'll just scratch those out, but I also do have handwritten answer keys for it, which will help you as you figure stuff up. Let me just hit pause before people ask me a bunch of questions.